Predicting risk matrix in software development projects using BERT and K-means. In software development projects, much time was spent tackling and repairing software defects. Before this happened, the developers had identified and recorded these risks in the risk register. However, prioritizing and selecting responses to these risks often takes a long time. So, we need a decision support system that runs automatically to help classify the risks. Approaches can be divided into two categories. The first approach is a risk classification based on the likelihood of occurring. The second approach analyzes the content of a given risk to determine how severe the risk will have an impact. Many studies have determined risk priorities using a risk matrix. However, these studies still use manual assessments to assess the magnitude of risk. To close this gap, research is carried out that can produce a model that can predict the magnitude of risk by utilizing artificial intelligence. The BERT model is the latest deep learning method based on natural language processing, which is one of the most successful models for contextual embedding, capturing complex query document relationships in ranking search. This study used 60,000 Stack Overflow datasets from Kaggle.com. Stack Overflow is a popular question and answer medium for sharing the experiences and expertise of software developers. This study proposed a risk matrix formation model, where the risk magnitude is the result of measuring the severity of the risk and the likelihood that the risk will arise. Pre-processing steps include merging between the title and body columns into a new column. Determine the maximum length by analyzing the word density in the dataset. Remove punctuation, change all words to lowercase, filter questions from meaningless words with stop words, URL removed with tweet preprocessor, convert words to their primary form with lematizer. We used the elbow method, the best approach to find the number of clusters in K-means. Each cluster member is counted and ranked to determine the probability scale of their occurrence. The technique used in this study is text blob sentiment polarity based on researchers' recommendations. The polarity of the result of the text blob process is divided into three parts: negative, normal, and positive. For the 5-level severity scale, the negative and positive polarities are divided into two halves, each with a median value of each polarity. The process of quantitative risk analysis is to analyze the probability of each risk and its consequences numerically. The risk matrix allows quantitative analysis and combination, where the horizontal direction determines the impact of the risk on the project, and the vertical direction determines the likelihood that the risk will occur. 4 scales determine risk priority. Each priority is represented by small, medium, high, and extreme. Cluster validation was carried out by text classification using BERT with 30 epochs to obtain an accuracy of 86%, and this value proves that the K-means and BERT algorithms are suitable for use in the risk matrix formation model. Model testing was also carried out on a list of risks assessed by other researchers. In this research, we have found the novelty by developing sentiment analysis and text likelihood ranking to determine priorities in software development. The dataset used is from a list of questions found on Stack Overflow. The proposed scheme is based on text input data, tokenization, clustering, and sentiment classification for risk impact prediction. This model is expected to be integrated into the risk management framework in software engineering. This model still relies on the results of text grouping, with the optimal number of clusters being 5 to form a 5 by 5 matrix. For this reason, it is necessary to validate the cluster results using the classification method. If the cluster validation results are less than 80%, it is recommended to use an algorithm other than k-means, provided that the validation results reach 80% or more. Thank you.